This is A Square Maths Made Easy Academy. In my today's video, we are going to continue from complex number. And this aspect of complex number, we're going to deal with what we call methods of representing a complex number. Now, after that, we're going to solve problems on those methods using the normal method and also using calculator method. I want you to watch this. Now, the topic here is method of solving a complex number. Now, there are three methods by which a complex number can be solved. Now, the first one is what we call use of rectangular form. Use of rectangular form. That is number one. And mathematically, this thing can be represented as z equal to x plus iy. Now, x stands for real part of what? Complex number. And y stands as what? Imaginary parts of what? Complex number. Are you with me now? Now, this is the first method by which a complex number can be represented. Now, the second one is what we call polar form. It's what we call what? Polar form method. Now, mathematically, polar form can be represented as z then equal to r open bracket cos theta plus I sine theta. Are you with me now? This is the second method of representing a complex number. YR is called the modulus. It's called the modulus. If you observe my previous video, I was able to say that modulus can be represented mathematically as x squared plus y squared, square root of x squared plus y squared. While this theta is called the argand or the argument. The argand or the argument, and the formula is always represented as theta equal to tan inverse of y over x. This is the first thing that you're going to start with. Then after that, you now identify the quadrant it falls. Are you with me now? Now I want you to observe again that this polar form of a complex number can be condensed to give us z equal to r cis theta. That is another way you can represent this particular polar form. So r stands as the modulus, c stands as cos, I stands as imaginary, s stands as sine, and this is the theta, which is the argand or amplitude that is governing both cos and sine. So this is number two method of representing a complex number. Now, can we observe the last one, which is number three? The last one is what we call Euler's form. Euler's form. And mathematically, it can be represented as z equal to r exponential I theta. Are you with me now? Now, this r is still modulus, and this one is still argand. These are the basic way by which you can represent a complex number. Are you with me? Now, method. Now, let's now look at one problem or one particular question under those methods listed above. Now, I want you to observe this question now. So, let's go to question number one. Now, the question says this. Watch. The question says express minus 1 plus square root of 3i in Euler form. In what? Euler's form. In Euler's form. Now, what are the options? Option A says 2 exponential 120 degrees I. Then option B says 2 exponential 60 degrees I. Option C says 2 exponential minus 120 degrees I. Then option D says 2 exponential minus 60 degrees. Are you with me? Now, what we are going to consider, since the question says we should express it in a Euler form. So the first thing is to state the method of Euler form, which says that z is equal to r exponential I theta. Are you with me? Now, the first thing we are going to generate is the modulus first. Remember, I said modulus r, the formula is square root of x squared plus y squared. Are you with me now? Then from the question, you agree with me that the value of x is minus 1, and the value of y is square root of 3. Now let's substitute. This will now give us square root of, now what is x? X is minus 1, then all squared, plus what is y? Square is square root 3, then all squared. If you now simplify, you are going to have your r to be square root of Minus 1 square will give you 1. Are you with me? How is it 1? I want you to watch. Minus 1 all square simply means minus 1 times minus 1. When minus cancels minus, it will remain 1 times 1, which is what? 1. I will now add. Now the next one is square root of 3 all square. What will happen here is that square root will cancel power 2. It will remain just 3. So which means here is 3. How? Square root of 3 all squared simply means we should expand square root of 3. How many times? 2 what? Times. So it will now give us square root of 3 times square root of 3 is square root of what? 9. And what is square root of 9 is what? 3. Now if you continue here now, this is now square root of 1 plus 3. What is the answer? 4. Then finally, the modulus is now square root of 4, which is what? 2. Are you with me now? Now we have gotten the modulus of the complex word number. Now our next target now is to find the what? Argand, which is the angle that exists. Are you with me now? Now how do we find the angle? I want you to observe something here. Anytime you are looking for the angle, please always represent it in a Cartesian word graph. How do I represent it? I want you to watch. The essence of doing that is to identify the quadrant in first. Now this is positive y. Are you with me? This is negative y. This is positive x, and this is negative what? X. Now the first one is your x, the second one is your what? Y. Now your x is minus what? 1. Now this is minus 1. So from this origin to this very particular one is minus what? 1. Then y is plus 3. So which means plus is we are moving up. So I will generate this line like this and form what we call a right angle triangle. Look at it here. And this vertical axis now is sod what? 3. Are you with me now? So you can see that this particular argand falls on the second what? Quadrant. How? This is exactly what we're looking for. From here and stop here. That is what we call the argand. The what? Argand. Are you with me now? But we have to call this alpha first of all. When we get this alpha, we can get the argand of this diagram. How? So let's start with now. Now this is alpha. Opposite over what? Adjacent. So we now use tan what? Alpha, which is opposite. Opposite is sod what? 3. While adjacent is minus what? 1. If I continue now, it will give me this over this will give me minus sod 3. I mean sod 3 over minus 1 should give me minus sod what? 3. Make alpha subject of the formula. I will now take the tan inverse so that I will have tan inverse of the right as square root of minus 3. But I want you to observe that if you look at this second quadrant, there is what we call all students take what? Coke. It is only sine theta that is positive. Then tan is what? Negative in the second what? Quadrant. Now this thing now can be removed out. You remove the minus here. Now outside, including the minus on the second what? Quadrant times another minus. So what remains now is tan inverse of what? Square root of what? 3. Are you with me? Then this still already cancelled. So can you see that alpha is just but what? Tan inverse of what? Square root of 3. Then what do we do? This is a special what? Angle. I will now draw an equilateral triangle that was bisected into 2. This one is 60 degrees and this one is what? 30 what? Degrees. Anytime you are observing this particular angle, this is a constant value, which is sod what? 3. This one is sod 2. And when this one is 2, and this one is what? 1. This is a right angle triangle. Remember, I'm dealing with this angle now, opposite over adjacent. So which means I will now say tan 60 degrees is now equal to opposite is sod 3. While adjacent is what? 1. If you divide it, it will give you sod 3. Are you there? My target is to make 60 degrees subject of the formula. Can we say 60 degrees is now equal to tan inverse of what? Square root of what? 3. Now let us make the comparison now. Now watch everyone. What is here? Alpha. What is here? 60. Which is alpha is 60 what? Degrees. Are you with me? What is here? Tan inverse. What is here? Tan inverse of sod what? 3. Can you see they correspond? So invariably we can now conclude by saying the value of alpha is what? 60 degrees. Don't be in a rush to say that the argand is 60 degrees. It is not what? 60 degrees, because we are looking for second what? Quadrant. What do? I will now remind you that theta plus alpha is always 180 degrees. This is for second what? Quadrant. Do you know why? This is angle on a straight what? Line. Since we have known alpha, we are looking for the argument now, which is theta. Theta will now become 180 degrees minus alpha, which is 180 degree minus alpha is what? 60 what degrees. Are you with me now? So finally, our argan now is now equal to 180 minus 60 degree will give us 120 what degree. Oh yes. Can you now observe that we have known all of them? We can now represent it in Euler word form. Euler's word form. How? I want you to watch. So this is the Euler form, right? So this is my z equal to, do we know the modulus? Yes, we have solved it. It is what? 2. Then exponential. The angle now is what? Not 60, it is 120 degrees. So 120 degrees times I will give us 120 degree what? I. Do you have something like that in the option? Yes. The correct answer is option what? A. Are you with me now? Now I want you to observe this. This is just the way. But if you are using calculator method, it's very simple. You are going to find only the modulus and the what? Argan. Then we now express it in what? Euler form. We are watch calculator method. I want you to observe this. Don't forget our target. Don't forget this. Are you watching it now? Oh yeah, look up everyone. Look up. Are you watching it now? Alright, now watch this. Clear the function key first. Punch shift. Okay, it's on. Punch what? Shift. Punch 9. Punch 3 equal to an AC to clear everything that has been stored in the calculator. Then let's operate the complex number. Now what do we do? First thing is to convert this to complex number. How? Punch mode 2. So I've told you in my previous video, it's already in a complex form. Then Q in the question. You know the first one is minus 1. Q in minus 1. Are you there? Then you now add. The second one is sod what? 3. Q in, so this is sod. Are you there? And this is what? 3. Then what you should do, navigate a little by pressing the right button, the forward button here, so that you can now punch I. How do I punch I? ENG. I will do what? Appear. Are you with me now? Now the next thing you are going to do is to punch shift and what? 2. So it's going to show you 4 things there. There is what we call a modulus and argument. Modulus and argument is number what? 3. Then punch what? 3. Are you there? Then punch equal to. Can you observe that the answer is what? 2 angle what? 120 degrees. So I don't need to solve it again. 2 angle 120 degrees. Oh yeah, watch this now. This is how we are going to put it now. Watch. This is polar form, right? I will now say Z, that 2 is the modulus in the calculator, then exponential, that angle theta is 120 degree. So 120 times I will give you 120 degree what? I. And that is the final what? Answer. Then in summary, I want you to observe something here. What if they ask you to convert it in polar word form? Now this is another question, and let's say in polar form. I say polar form is what? Z equal to R, open bracket, cos theta plus I what? Sin what? Theta. We have known already the modulus. The modulus is what? 2. Then open the bracket. This is cos, angle is already 120 degrees. Plus what? I sin. The same thing is 120 what degrees. Are you there now? Now this is the answer. But I want to convert it in a 6 form. I will now write 2 and write 6. The angle is what? 120 degrees. And that is the final answer in polar word form. Now see you in my next video. Thank you.